Here we'll talk about the multiplication rule for probability, and we'll specifically talk about the multiplication rule for independent events. We say events A and B are independent if the fact that A occurs does not affect the probability that B occurs. For example, if I roll a dice and then roll a second dice, what I got on the first roll does not affect what I get on the second roll. So those would be independent events. If I have a deck of cards and I draw a card and then return it to the deck and shuffle and draw another card, what I drew the first time does not affect what I draw the second time. So those are independent. However, if I were to draw that card and take it out of the deck and then draw a second card, that would affect the probability of the second card, and so those events would not be independent. We'll look at the first multiplication rule, which specifically deals with independent events. If two events A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. And once again, we may see this written using our intersect notation. Probability of A intersect B is equal to probability of A times the probability of B. Therefore, as long as our events are independent, all we need to do is multiply. Let's consider if we flip a coin and then roll a dice. These will be independent since the coin toss should not determine any probability on my die roll. We're going to see the chance of getting a tails and a 3. The chance of getting tails is 1/2, and the chance of getting a 3 is 1 out of 6. Therefore, we just multiply. The chance of getting both of these is 1/12. We can also write this as a decimal, 0.8083, or as a percent, 8.3%. Let's consider drawing two cards with replacement. The chance of getting a king and then getting an ace. We start with a king. There are 4 kings in the deck. And there are also 4 aces in the deck. So we just need to multiply these two numbers. When we do, since this is going to be such a big number, we'll just write it as a decimal, 0.0059, or 0.59%. So this is a very small probability. Let's consider we have this bag that contains 4 red balls, 3 yellow balls, and 5 black balls. And we're going to draw them. Draw one, record its color, put it back in the bag, and draw a second one. We want to know the chance of selecting 2 yellow balls. Well, there are 3 yellow balls, and we have a total of 12 balls. And then for the second one, we still have a chance of 3 out of 12. Therefore, when we multiply these, we get 0.0625, or 6.25% chance. Let's now consider the chance of selecting 1 red ball and then 1 black ball. For the red, we have 4 out of 12, and for the black, we have 5 out of 12. Once we multiply these, we get 0.139, or 13.9%. Finally, we'll look at the chance of selecting 1 yellow ball and 1 red ball. We have a chance of 3 out of 12 to select a yellow and 4 out of 12 to select a red. And when we multiply these, we'll get 0.083, or 8.3%.